So much of the technology we use every day, it honestly feels like magic, right? It just seems to know what we want, it organizes our lives, it even understands us. But here's the thing, it's not magic. It's something we can actually wrap our heads around, and today, we're going to pull back that curtain.
I mean, think about it. You finish a video, and boom, the next recommendation is exactly what you were in the mood for. How on earth does it do that?
Or how about your email? Your inbox is probably pretty clean, all things considered. That's because there's this invisible bodyguard working 24/7, catching all the junk and learning new tricks to keep it out.
And this one still feels like we're living in the future. You can just talk to your phone and it gets you. It sets timers, answers your random questions, sends text for you, all just from the sound of your voice.
So that's the real question, isn't it? These aren't just simple programs that are following a strict list of commands. No way. They're changing, they're adapting, they're getting smarter. In other words, they're learning. And the incredible field that makes all of this happen is called machine learning. All right, let's really get into it. And to understand what machine learning is all about, we're going to use an example I think we can all appreciate, the trusty old spam filter.
Okay, first, let's just imagine trying to build one the old-fashioned way, before machine learning was a thing. We'd have to put on our 90s programmer hat.
So you'd look at a mountain of spam emails, and you'd start noticing patterns, words like free or credit card. Then you'd have to sit down and write a massive, complicated list of rules. If an email has this word but not that word, mark it as spam. The problem is, as soon as spammers get clever and start writing FR33 instead of free, your rule breaks. You have to go back in and add another one. It's a non-stop, exhausting game of cat and mouse.
This is where everything changes. The machine learning way flips the whole idea on its head. Instead of giving the computer a giant rule book on how to spot spam, you just show it a ton of examples. You feed it thousands of emails you already know are spam and thousands that aren't, and you just say, you figure out the pattern. The system learns on its own, and even better, it keeps learning as the spammers change their game.
And believe it or not, this core idea has been around since 1959. A pioneer named Arthur Samuel nailed it. The key phrase here is without being explicitly programmed. It's the difference between giving someone turn-by-turn directions and just giving them a map and a destination and letting them figure out the best route through experience.
Now, what's really cool is that there are different ways for machines to learn. The most common one is called supervised learning. And honestly, the best way to think about it is like a student learning with a teacher who has all the answers.
So with supervised learning, the data you feed the machine already has the answers included. We call these labels. For our spam filter, that means every single email we give it is already neatly labeled as either spam or ham, which is just a funny name for a normal good email. The algorithm crunches through all those examples and starts to connect the dots between the words in an email and its correct label. This learning with a teacher approach is perfect for two main kinds of jobs. The first is classification. That's just sorting things into buckets. Is this spam or not spam? Is this picture a cat or a dog? The second is regression, which is all about predicting a number. For example, looking at a car's mileage, year, and model to predict its price.
Okay, but what happens when you don't have a teacher? What if you just have a giant pile of data with no labels, no answers? Well, this is where things get really interesting. Welcome to the world of unsupervised learning.
With unsupervised learning, you're essentially giving the algorithm a huge, messy data set and just one instruction. Find something interesting in here. The system has to look for patterns, for structures, for connections, all by itself. It's like being a detective with no clues to start with.
And this is super powerful for things like clustering. Say, a shopping site could use it to discover different groups of customers based on what they buy, without ever being told what groups to look for. It's also great for anomaly detection. Your bank uses this to spot a weird transaction on your credit card that just doesn't fit your normal spending pattern. And then there's dimensionality reduction, which sounds way more complicated than it is. It's basically about taking super complex data and boiling it down to just the most important parts.
So you might be thinking, if these ideas have been around since the 50s, why does it feel like machine learning has just exploded in the last 10 years? Why is it sudden everywhere?
Well, the truth is, we are living through a full-blown technological tsunami. Machine learning has officially broken out of the research lab and is now the engine behind so many of the high-tech products we can't live without. And this happened because two very important puzzle pieces finally snapped into place at the same time.
First, we got the fuel. Massive amounts of data. These algorithms are incredibly data hungry.
They need millions of examples to learn from. And thanks to the internet, we are creating unimaginable amounts of data every single day. Second, we got the engine. Insane computing power. Training these models is a heavy, heavy lift. But thanks to powerful processors, especially GPUs, we finally have the raw horsepower to actually do it.
So when we pull it all together, it's not magic, right? It's a completely new way to solve problems, where systems learn from raw experience instead of rigid instructions. Sometimes they learn with a teacher. That's supervised learning. And sometimes they have to figure it all out on their own. That's unsupervised learning. And this entire revolution is happening right now because we finally have the perfect recipe, the fuel of big data and the engine of massive computing power.
And all of this leaves us with one final, very big question. We have actually built machines that can learn. They can see patterns that we miss and solve problems in ways we'd never think of. The technology is here, and it's getting more powerful by the day. So the question isn't really, can they learn anymore? The question we all need to start asking is, what do we want to teach them next?